Engineering Physics Lab. Experiment number 2 and dielectric constant. The aim of the experiment is to determine the dielectric constant of the given material using capacitor-resistor circuit. Operators required. We need a circuit board which has the electronic components like resistor, capacitor, voltmeter and etc. So this is the dielectric constant electrical circuit. So in any electronic circuit, if there is a line between two terminals, it means it is connected. Here X to A, no connection. We have to connect the power supply to the electronic board. And we have the resistor, as connect from resistor to resistor. We have three values of resistors. So I'll be using 100 kilo ohms. Connect resistor to the resistor. Then we have the capacitor. We have three values. I'll be using C1 capacitor. Connect capacitor one terminal to the other. Next we have the voltmeter. Here DVM is nothing but digital voltmeter. Connect positive terminal of the voltmeter to the positive and negative to the negative. And we have to observe three knobs. The first one is the charging and discharging. Then start and pause the stop clock. Switch on the circuit. Suppose if the stop clock is not 0, reset it. And suppose if the capacitor is not 0, you have to discharge the charges abruptly. To do that, take out one end of the capacitor and touch to the other end. And while you start the experiment, keep the knob to be in the discharging and press the charging and start button simultaneously. And start taking readings for every 5 seconds. What is the value of the voltmeter for 5 seconds? And wait till 10 seconds and note down the value. 15 seconds, note down the value. 20 seconds, note down the value. 25 seconds, note down the value. 30 seconds, it is 4.13. Likewise, 35, 4.22. You wait till 60 seconds. You have to note down for every seconds, every 5 seconds till 60 seconds. As soon as you reach 60 seconds, listen to me carefully. You have to press knob of reset and discharging simultaneously. 60 seconds I pressed. Again start noting down the voltage value for 5 seconds 2.62. For 10 seconds 1.61. Likewise up to 60 seconds you have to go on noting down the voltage value of a capacitor as a function of the time in seconds. This is the experimental setup. So once you complete taking readings, coming to the tabular column, you have to note down time versus the voltage, charging, whatever the value you will get for the 60th second. So keep the same value for the 0 second of discharging. Okay. Then 5 seconds, what is the value? 10 seconds, what is the value? Note down up to 60. This is one of the tabular column which we have taken the readings already. Coming to calculation, so length of the capacitor plate L, breadth of the capacitor plate B, distance between two plates of capacitor D value, everything will be given. So I know what is the length, I know what is the breadth. So to calculate, just multiply the length value and the breadth value and you will get the area value. Since it is length into breadth, meter into meter, meter square, T of you will get from the graph. Resistor, it is given value, and epsilon naught is also a permittivity of free space 8.854 into 10 power minus 12 pico per meter. Here T of is the time required for 50% of charging or discharging. T of. Okay. Now only thing you don't know here is T of. This is the formula for dielectric constant. Epsilon R is the dielectric constant, relative permittivity. So T is distance between two plates of capacitor, 10 power minus 6, 0.693 epsilon permittivity of free space. A is the area, R is the resistor value. What do you know from this? It is the TF value. To calculate the TF value, you have to plot the graph time in seconds versus voltage in volts. Okay. And this is the charging curve and this is the discharging curve, where these two meets up when you plot the graph, and from that point draw a vertical line, that will be your TF value, and substitute to this and you will get the dielectric constant value. This is one of the graph which you have plotted already. And results, and express the whatever the results you will get from the dielectric constant formula. And remember, for a dielectric paper, the dielectric constant value will be between 3 to 4. Since it is constant, there will be no SI unit.